Okay, so we've just gone through how to do multiple regression in our different programs. What we're going to do now is going to run through some diagnostics on how good our models are. And there's a few different indicators we're going to want to use to be able to look at that. Now, we can do a little bit in Excel, but we want to use some of those more powerful programs to do some of the testing that we need to. So I'll show you how to do this in this program. We'll start off in Excel. So here we are in Excel. And remember, if I had just done my multiple regression by clicking on Data Analysis and going to Regression. So we see my X and Y values are still in there from last time I ran the regression. This time, I just want to select these plots that will give me residuals and normality plots. I'm just going to select these things and hit OK. Now, what it does is it gives me a new output, which is the same coefficients I had before, but I have some new plots that I can look at. So, a normality probability plot, so that's like a QQ plot of sales against sample percentiles. We want that to be on a roughly diagonal line, which it looks like it. Airplay fit plot, adverts fit plot, but then these two residual plots. And these are the ones we want to look at to see if it looks like our residuals are distributed fairly evenly as we go up in airplay. And it looks like it is. It doesn't look like there's too much of a deviation across these. And it's the same thing in our advertisement. It looks like it maybe gets a little bit smaller, a little bit funneled, but that might just be due to the sort of amount of data that we have out here. Okay, so that's all we can really do in Excel. So let's move on to JASP, which has a lot more different diagnostics for our multiple regression analyses. So if I open back up JASP, we see we've got our linear regression where I had done the adverts and airplay as the two variables that we're going to use to predict sales. So if I scroll down now, I'm going to close up model. I'm going to scroll down to statistics. And there's a few parts I want in here. I want to select maybe descriptives and collinearity diagnostics, along with residual statistics, Durbin-Watson, case-wide diagnostics, and then we'll see, do I need anything else? Method specification. I'm not going to worry about this because that has to do with how we're going to enter our data, but we've already used that entry method. And plots, what types do we want to use? I'm going to give us our residuals versus predicted plot, a QQ plot of standardized residuals, and that should be good. So now what we see in our output here is we have under our model summary, we also have our Durbin-Watson. And remember that we want our statistic to be not that much different than 2. If it's less than 1 or greater than 3, that might indicate that you've got a problem. What we've got here is our collinearity diagnostics. And we see that if we look at tolerance, remember we don't want tolerance below 0.5 really. That could indicate a problem. And we don't want any single VIF to be greater than 10. Or we don't want to see the average VIF, that would just be looking at all of these, to be much different than 1. So we see here we look pretty good across the board here. We've got a little bit more in collinearity diagnostics we don't have to worry about. And we can look at our case-wise diagnostics. And what we've done is we've looked for a case-wise diagnostics anything that has a standardized residual at this point greater than 3. But we can set this to different values. I could set this to 2.5. And we'll see we'll probably get a few different values. So now I've got case number 1 has a standardized residual of 2.7. Remember, that's number of z-scores. So that's how far that residual is away from the mean, suggesting it's an outlier point. And case number 169 is 3.178. Standard deviations away from the mean. So these might cause concern, and you might want to look at those just to make sure that they're not error points or they're not problem points that you need to take out for some other reason. So the last thing we have here is our standardized residuals versus our predicted values. And we want to see sort of a cloud here. We don't want to see any kind of pattern to these results where you've got a large amount of error at one end of the predicted variables and it funnels down to something smaller at another end, or the other way around. So this looks pretty good. It looks like the residuals are distributed fairly uniformly. It's kind of blob-like. And we can confirm that by looking at a QQ plot of the standardized residuals. And remember, at our QQ plot, it would suggest if they fall along this line nicely, they're not much different than normal distribution. So it looks like we're pretty good in terms of our normal distribution of residuals. The last thing we may want to do is look at any Cook's distances that are greater than 1 here instead, in our case-wise diagnostics. And it doesn't look like we've got any problems in terms of leverage. That's where we would see our Cook's distance be way outside of 1 in this case. So it looks pretty good in this case. So based on our diagnostics here, it looks like our predictors aren't biased in a way that's going to change our interpretation of the data. Okay, so let's see how we do this same thing in SPSS. So I'll open up SPSS, back up to the data file that we had before. So the way we're going to do diagnostics in SPSS is by doing them while we're doing our multiple regression. So if I go up to Analyze, Regression, Linear, and what we see is I had 2 blocks of regression set here, where I had either the single predictor or 2 predictors. So I'm just going to get rid of the single predictor version first. And then my next block, here's the one that I'm going to be running. Now, I'm going to click on Statistics, and in this case, I want residuals, I want to do Durbin-Watson, and I want case-wise diagnostics with outliers, again, let's say outside of 2.5 standard deviations in this case. We could use 3, we could use whatever we think is going to constitute an outlier. Hit Continue. Oh, the last thing I want to do is I want to click on collinearity diagnostics in this case. Continue. So the other thing I can do is look at a plot of residuals. But we'll do that in the next step. So let's just hit OK on that. What we see is, in this case, we get Durbin-Watson here, value of 2.055 for our model. And what this shows us is that we don't want this anywhere outside of 2, really. So less than 1 or greater than 3 could show that there's some autocorrelation problems in our data. Ours looks fine in this case. Our collinearity diagnostics, remember, we want to see that our tolerance is not below 0.5 and that our max VIF is not greater than 10 or our average VIF is not greater than 1 in a substantial way. And we see we've got the same collinearity diagnostics, but we don't need to worry about this at this point. We have case-wise diagnostics, so the same sort of thing we saw in JASP, where we get case number 1 has a large standardized residual, and case number 169 has a large standardized residual. We may want to look at those values and see if there's any problems. Okay, so let's move on and take a look at a couple of other diagnostics we can do. So I'm going to go back to Analyze, Regression, Linear. And I want to look at plots and this Save button. So the first one I'm going to do is look at plots, and I need to look at my standardized residuals, that'll be on the y-axis, as a function of my standardized predictors. So what that does is that's a z-score of residuals and z-score predictor. And let's give a normal probability plot And I'm not going to worry. Let's get a histogram too, sure. Okay. The other thing I'm going to do is click on Save. And what I want is I want cooks and I want leverage values. Okay? So if I hit Continue and then I run this analysis, you see I get the same thing out, but further down, I've got a histogram of my standardized residuals. And happily, they look fairly normally distributed. I can confirm that really looking at the QQ plot, right? This is a PP plot in this case, but it's very much the same thing. My last one is my standardized predicted residuals versus my standardized predictor. And we see again, this is sort of blob shaped, suggesting that as my predictor goes up, the variability in my standardized residuals doesn't look like it's much different. All right. So the other thing I ended up getting is I've got two new output variables here, Cook's distance values and my centered leverage values. And remember, I don't want to see any Cook's distance values really any greater than 1. And on my centered leverage values, I don't really want to see any that are 3 times the mean. So what I can do is get some descriptive statistics on these to see what I've got. Remember, I again need the mean and the max of those. So if I go to Analyze, Descriptive Statistics, Descriptives, and I do descriptives on my Cook's distance and centered leverage values, add those in. Do I need to take options? Let's see, minimum, maximum. I need my mean. That's really what I need in these cases. Continue and OK. So what we see in terms of my descriptive statistics down here is my maximum Cook's distance is 0.695. So I'm OK there. Average or mean centered leverage is 0.01. And remember, I don't want this to be any more than 3 times that. And it looks like it is. This is 3 times that would be 0.03, and my maximum is 0.05. So I might have a leverage value. And because I've had some case-wise diagnostics suggesting that I've got these outliers, these two might be resulting in some leverage problems that we might want to look into. The last thing we could do if we wanted to is we can analyze regression linear. Now, if I go save standardized residuals, what I can do is use that to look at the skewness, kurtosis, and do tests of normality on my standardized and unstandardized residuals if I want to do that. Okay, so let's look at our multiple regression diagnostics in R. Okay, so the first thing that we probably want to do is we want to install a new package called CAR. And just like it sounds, CAR. It is the companion to applied regression. So we would just go to Packages, Install, and look for CAR. Do that, click on Install, and we'll see that it will take a little bit of time, and it will unpack and install that package. Okay, so once that's done, we're going to do some diagnostics on the regressions that we've just run. Remember, we had multiple regression 2, right? And that was the one where we had the 2 predictors for record sales in our model. So that was advertising budget and number of airplays. So what we're going to do is do some diagnostics on this. The first thing we're going to do is we're going to look for some outliers. So I'm going to just create a new heading here called diagnostic. So anything I put with a little pound sign hashtag in front it's just a comment, so it's not going to do anything if I try and run it. Okay, so the first thing we'll do is we're going to do an outlier test, and what we're going to use is outlier test, that's with a capital T, and then we're going to select the model that we want, which was mreg2.model. And if I just run that command, Control Enter, that's because I didn't load my package car. Right. So now I've loaded my package car. So in this case, before I do my diagnostics, maybe I want to library car. Okay. I've already done that, but that's okay. So now I'm going to run this command. And what we see is I've got case number 169 shows a unadjusted. This is basically 3.25 T distributions away. So it's not using a Z distribution. That's why it's this R student. But this is the same thing. It's really giving us how far away from the mean is this point. So we see that we've got an outlier here at 169. And that case is the same one that we saw in SPSS and in JASP. Okay, so that gives us an idea of what our data looks like. So we might want to look at the normality of our data, how it looks. One way we can do that is by doing a bunch of different plots of the model at the same time. So if we want to, one thing we could do is use this command called par mf row equals C2, 2. And what this will do is allow us to turn our model, instead of throwing up our 4 graphs that's going to complete at once on that, it's going to put them in a set of 4 for us here in this window. It'll just make our lives a little bit nicer to look at. I think I've got an extra bracket in there. Nope, I don't. There we go. Control Enter. Now you see that didn't do anything, but what it's done is said, in the next command, when I do a plot, I wanted to put it in a 2x2 matrix. So if I go plot mreg2.model, Control Enter, what we see is behind me, and I'm going to just move this over so you can see it a little bit nicer. So here what we see is we've got our residuals versus fitted model, right? We see our outlier at 169, our normal QQ plot, which gives us our distribution along the normalized quantile line. It looks pretty good. And a couple of other standardized residuals against fitted values and residuals versus leverage. And what we could see is that it's giving us a couple of indications that we've got some problems with point number 169 and point number 1. We see that here, we see that here, we see that here. And remember, those are the ones that we identified even in the other programs as being potentially problematic or being outlier values. So that gives us more indication that we may want to have a look at those values. We look down here, you see it. Okay, so now that we've done that, we could do another model if we wanted to. So if I wanted to plot fitted mreg2.model, comma, residuals mreg2.model. Control Enter. I should put that really up here in my script so I keep saving that. What we have is our fitted against our residuals, and again, this should look kind of blob-shaped, and it does, so we're fairly happy with the way this looks. But we will do some tests of normality. So we can do some more tests. We could do a histogram. So, hist of residuals mreg2.model. Right? So this should give me a histogram, Control Enter, of the distribution of my residuals, which is nice. It looks fairly normally distributed, as you can see here. Looks pretty good to me. And then I can do a QQ plot separately if I want. So I'm going to, in fact, just copy this, paste it. And instead of hist, it's going to be QQ norm. Take that, Control Enter, and I get my normalized QQ plot of that as well. One last thing I can do, which is pretty nice, is a Shapiro.test, and I'm going to do that on my residuals of this model as well. So I'm going to do a Shapiro test on residuals of mreg2.model. And what we see is I've got a p-value of 0.2741, and what's nice about that is it tells me that I do have normally distributed. They're not significantly non-normally distributed, my residuals. So I can have fairly good confidence in the normality of the distribution of my residuals. Okay, so another thing that we would want to do is check for our autocorrelation using a Durbin-Watson test. And happily, we can just use, I believe it's Durbin-Watson test. I started typing that in. So Durbin-Watson test of my model, which is mreg2.model. Control Enter. And what we see is, again, my Durbin-Watson statistic is 2.05. Remember, we don't want that to be less than 1 or greater than 3, because that would indicate some significant autocorrelation. But looks like we're pretty good at this point. The other one we want to do to test for multicollinearity would be a test of our VIF. So we just use a command VIF, and it would be mreg2.model. Control Enter that, and we see that I get my VIFs of 1.01 and 1.01. Remember, we don't want either of those to be greater than 10, and we don't want the average of those to be much greater than 1. Okay, so we could do a couple of other diagnostics on the collinearity, but we're going to just sort of leave it at that, and we'll just move on to leverage. So one thing I can do is actually use a command called leverage plots. And I'm going to do leverage plots of mreg2.model. Remember, I need to hit Control Enter when I'm in the script up here. And we can see from our leverage plots, so here this is adverts, and it shows these different values that might be giving us or causing us leverage. And again, it's noted 169 and 1 that might be causing undue influence. So we might want to look at those. These ones don't look as bad, but note that these ones are quite far away as well. They might be pulling this regression line up. On AirPlay versus others, we can see it's pretty much the same thing here. We can see that we've got these same values, 169 and 1, 42 and 119. So these are just values we may want to look into to see if there's any problems in terms of leverage. Now, in order to do diagnostics on leverage values, remember we want to use Cook's distances. And the way we do that in R is by using a command called Cook's distance. So I'm going to make a new object called mreg2.cooks. And into that, I'm going to put Cook's distance of mreg2 dot model. And now what that should have done is created a new object here. And all that is that's a list of Cook's distances for that entire model. And then what we can do is we can look for max values. Remember, Cook's distances, we should have none greater than 1. So now all I need to do is do a max of mreg2.cooks. And I see that my max Cook's distance is 0.69. So I'm okay, 0.069. So it's much less than 1. So that's good at this point. So it doesn't look like I've got any massively problematic leverage values. Another thing I could do is create a list of centered leverage values. And remember that we don't want any to be greater than 3 times the mean centered leverage. So what we're going to do is make a new object again, and I'm going to call it mreg2.lev. And into that, I need to use the command hat values. So it's hat values of the model, which is mreg2.model. So mreg2.lev is going to be my centered leverage values for the multiple regression model that I have. Control Enter. And then what I can do is look at the max and look at the mean of that value. So if I look at max of mreg2.lev, Control Enter, I see it's 0.063. And what is the mean of mreg2.lev? 0.015. So what we see is we don't want values greater than this. So this statistic would suggest that there's some values in here that are causing some undue leverage over the regression line. And from these leverage plots, we can suggest that those might be 169 or 1, especially since those stood out as outliers before. So we want to look at those and determine whether or not they are problematic for our data set. Okay, so hopefully that's given you a good idea of how to use all of the different programs that we've got to be able to do the diagnostic tests on your multiple regression models. And we can use some of these tests later on when we get into mixed effects models as well. So until then, I'll see you next time.